Hey folks, thought I'd work through most of the items on practice test 1. And the first one that I had on practice test 1 was to solve this rational inequality. And I said to write your answer using interval notation. So if you recall how to solve a rational inequality, probably the first thing you should do is make sure that the numerator and denominator are completely factored. Here, both of them are completely factored. And then you want to find what values of x makes the numerator 0 and what values of x makes the denominator 0. Well, the numerator is equal to 0 at 9 and the denominator is equal to 0 at -8. And now you remember what you do? You make a number line, put those values of x where the numerator is 0 and where the denominator is 0 on the number line. So I'm going to say here's -8 and here's 9. And remember the bookkeeping, at least in my video, I showed the bookkeeping that up here you list the factors of the numerator. And then I made a dashed line coming up from each. And then I said x minus 9 is 0 at 9, and x plus 8 is 0 at -8. And then remember the process to go through. Pick a number that you know is definitely in the interval from -infinity to -8. Say -10. Put -10 in here for x. Does it give you a positive or a negative? Well, -10 minus 9 is -19, so it's negative. Put -10 in here for x. -10 plus 8 is -2, so negative. Move to the next interval. -8 to 9. Pick any number that is in that interval, like 0. Put 0 in here for x. What comes out, positive or negative? Well, negative. Put 0 in here for x. What comes out, positive or negative? Positive. Now we move to the third interval, 9 to infinity. Repeat the process. Pick any number that you know is in this interval. Say 10. Put it in here for x. What comes out? Well, 10 minus 9 is positive 1, so positive. Put it in here for x. 10 plus 8 is 18. That's positive. And then what we do is we notice that when you take x minus 9 and divide it by x plus 8, on this interval from -infinity to -8, that would be a negative divided by a negative. Negative divided by negative is positive. On this interval, it would be a negative divided by a positive. Well, negative divided by a positive is negative. And then on this interval, it's positive divided by positive, which is positive. And it's this line right here that will answer the inequality. When is x minus 9 divided by x plus 8 greater than 0? When is it positive? Well, on the interval -infinity to -8. And on the interval 9 to infinity. So my answer, written in interval notation, would be -infinity to -8, -infinity to -8, union with 9 to infinity. So that's the answer to number 1. All right, here number 2, I ask you to, in 2 parts. Part A, I ask you to find the midpoint of the line segment that joins these 2 points. And then in part B, I ask you to find the distance between these 2 points. So now remember, to find a midpoint, it's kind of like finding an average. You find the average of the x coordinates, find the average of the y coordinates. So very quickly, we get the midpoint to be, well, to get the average of the x coordinates, I would add these and divide by 2. So 8x plus 9x, that's 17x, divided by 2. The average of the y coordinates, I add them. 7 and 8 is 15, divide by 2. So that's the midpoint. In part B, you have to know the distance formula, so recall that the distance between 2 points is the square root of x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. And we just substitute in. So I'd have a -7 minus 0 negative 7 minus 0 squared plus 4 minus 0 squared. Now let's see, negative 7 minus 0, that's, well, negative 7. Negative 7 squared is 49. 4 minus 0 is 4. 4 squared is 16. And 49 plus 16 gives us the distance to be the square root of 65. And that's all there is here to number 2, finding a midpoint and finding a distance. Alright, hey, in number 3 I asked you to find the standard form of the equation of a circle that has a center at 0, negative 6, and a radius of r equals 1. Recall that the general form, the standard form looks like this. X minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. Where hk, that would be where the center is located. So 0 is h, negative 6 is k. That gives us an x minus 0 quantity squared plus a y minus a negative 6. So y minus negative 6 is y plus 6. And r is 1. So it looks like, just cleaning this up a little bit, we get x squared plus a y plus 6 quantity squared equals 1. That's the equation of the circle. And that's all there is to number 3. Hey, in number 4, I asked you to determine the equation of the line that has a slope of negative 8/9, and it passes through the point 4, 4. Then I said, write your answer in slope-intercept form. All right, folks, here's the deal. You know a point on the line, and you know the slope of the line. You know a point, you know the slope. Why don't you use point-slope form to get started? So remember, point-slope form is y minus y1 equals m times x minus x sub 1. And then just substitute in what you know. So you have a y minus 4 equals, slope is negative 8/9, x minus 4. So now to get this into the slope-intercept form, we need to distribute that negative 8/9. And let's see, negative 8/9 times a negative 4, that's a 32/9. And then add 4 to both sides. So you get y equals a negative 8/9 x. See, I add 4. I need to get a common denominator. 4 is 36 over 9. So 32 over 9 plus 36 over 9 is 68 over 9. So this is your answer in slope-intercept form. And, well, that's it for number 4. All right, hey, here in number 5, I asked you to graph the linear equation 5x plus 3y equals 15 and to label the coordinates of the x and y intercepts. So, well, why don't we start with that? Let's find the x-intercept, and let's find the y-intercept. So now remember, to get the x-intercept, you're going to let y equal 0. So you put 0 in for y. Well, 3 times 0 is 0. So you get 5x equals 15. Divide both sides by 5. X is 3. So the x-intercept is 3, 0. To get the y-intercept, remember, to get the y-intercept, you're going to let x equal 0. So put 0 in here for x. 5 times 0 is 0. So you have a 3y equals 15. Divide both sides by 3. And you get y equals 5. So the y-intercept is 0, 5. So let's see if I can get a decent looking graph here. Let's see, I'll plot the x-intercept. The x-intercept's 3, 0. So that's right here, 3, 0. The y-intercept is 0, 5. So that's right here. Y-intercept is 0, 5. X-intercept is 3, 0. Draw a line through those 2 points. And that's it. That's the graph of the linear equation, 5x plus 3y equals 15, with the x-intercept and y-intercept labeled. So that's it for number 5. All right, here in number 6, I ask you to determine the equation of a line that is perpendicular to this line, and it passes through the point 0, 3. And write your answer in slope-intercept form. So let's see where we have to begin here. We want to come up with a line that's perpendicular to this line. We need to start off by finding or determining the slope of this line. So here's how I'm going to get the slope of that line there. I'm going to put it into slope-intercept form. So to put it in slope-intercept form, I'd start off by subtracting 5x from both sides. Then divide both sides by -6. And, okay, so this is the equation of this beastie, but now it's in slope-intercept form. And now I can see that the slope of the line, the slope of this line, the slope is 5, 6. Well, if the slope of this line is 5, 6, any line that's perpendicular to it must have a slope that is the negative reciprocal of this line. Well, if this line has a slope of 5, 6, a line that's perpendicular must have a slope of -6/5. See, the reciprocal, and then take the opposite of it. So let's see where we're at. Now what I'm trying to find is the equation of a line, perpendicular line, but I know the slope of the line is -6/5, and it passes through the point 0, 3. I was given the y-intercept. So since I was given the y-intercept, I'm going to use the slope-intercept form of a line. I'm going to immediately use y equals mx plus b to get the equation of -6/5 x plus 3. And that's it. That's my answer. It's already in slope-intercept form. So that's it for number 6. At this point, we're about halfway through the sample test, and I hope everything so far, so good. I hope everything's treating you well. All right, hey, here in number 7, I asked you to evaluate and simplify f of x plus h minus f of x all over h for the function x squared plus 9x minus 8. So, well, here we go to get started. Remember to determine the f of x plus h. Wherever you see an x, you're going to substitute in x plus h. So f of x plus h, well, that's an x plus h quantity squared plus 9 times x plus h minus 8. All of this is f of x plus h. Okay, now minus f of x. So minus f of x. Well, f of x is this beastie. I better put it in parentheses. And then all of that junk over h. And now we just got to clean it up. Technically we've evaluated, now we need to simplify. And to simplify we clean up by taking x plus h and squaring it. So x plus h times x plus h will give me an x squared plus a 2xh plus an h squared. Distribute the 9 here, so you get a 9x plus a 9h, then minus 8. Let's distribute the negative, so we get negative x squared minus 9x plus 8, all of that junk over h. And then fortunately for us, we have some stuff that will cancel out here. The x squareds will cancel out, so let's cancel out the x squared. Well, the 9x's cancel out, that's cool, and the 8's cancel out. So we had a lot of stuff cancel out of the numerator. So here's what we have left in the numerator. We have a 2xh plus an h squared plus a 9h. Okay, we're almost done. Look in the numerator, you can factor out an h. So we factor an h out of the numerator. And once we factor an h out of the numerator, we can cancel the h out. So cancel, and we get a 2x plus h plus 9. So that's what we get as our simplified answer. And that's all there is for number 7. All right, folks, here in number 8, I asked you to find the domain of the function h of x equals x minus 2 over x cubed minus 49x, and to write the domain in interval notation. So, well, here we are. We have a rational function. We have things to worry about here. We have to worry about any value of x that would make the denominator 0. You can't have 0 in a denominator. So how I would start this problem is I'd start off by trying to completely factor the denominator. Notice the first thing we can take out is an x. And then once we factor out that x, well, we can factor the x squared minus 49. That's a difference of 2 squares. So I see 3 values of x that will make the denominator 0. 0, that will make the denominator 0. 7 will make the denominator 0. And negative 7 will make the denominator 0. So these 3 values of x are not in the domain. Anything else can go in for x. Anything else is okay. These are the 3 bad values of x. So here's how I'll write my answer in interval notation. Negative infinity, I can pick any number from negative infinity up to negative 7. But don't include negative 7. Union with any number from negative 7 to 0. Union with, I have to bring it down to another line, any number from 0 to 7. And then union with any number from 7 to infinity. So that would be it. That's the domain of this function. You're not allowed to put 0, 7, or negative 7 in here for x, because that would produce 0 in the denominator, and that's bad. So that's it for 7. All right, hey, for number 9, I'm not going to draw the graph up here. You can see the graph, on the practice test itself. But by looking at the graph, you're supposed to determine if the function is an even function, an odd function, or neither, and explain your answer. When I look at the graph, to me the graph is symmetric about the origin. Since it's symmetric about the origin, it is an odd function. So the answer for number 9, it is an odd function because the graph is symmetric about the origin. Remember, if the graph is symmetric about the y-axis, then it's an even function. But the answer for 9, odd function, symmetric about the origin. For number 10, and again, I'm not going to draw this graph because you can see the graph on the practice test. It says, for the given graph, can you classify the following function values as positive, negative, or 0? Remember, function values. Function values are the y's, the y values, the y coordinates of points. If we are positive, we should be above the x-axis. Negative, below the x-axis. 0, right on the x-axis. So for A, it says, what's the f of negative 40? Well, I look for negative 40 on my x-axis, and I see the point on the graph is above the x-axis. So that means for part A, f of negative 40 is positive. Part B, f of 10. Well, that point would be below the x-axis. So that means f of 10 is negative. And then part C, what's the f of 50? Well, that's right where we're on the x-axis. So for part C, f of 50 is 0. And that's it for 10. All right, hey, here in number 11, I asked you to make a neat, concise graph of the piecewise defined function, negative x plus 2 when x is less than 0, square root x plus 3 when x is greater than or equal to 0. I'm going to do the second piece first, for when x is greater than or equal to 0. So let's put 0 in here for x. Square root of 0 is 0. 0 plus 3, well, that's 3. In fact, we should know the graph of square root of x plus 3. It's the graph of square root of x just shifted up 3 units. So for x greater than or equal to 0, so from here out to here, that's what the graph would be. Now for the negative values of x, we're graphing negative x plus 2. Now I can't put 0 in here for x because it's in this part of the rule. But if I were to put 0 in here for x, out would come a 2. I can't put a filled in circle here at 0, 2. I put an open circle. And then it looks like if x has a value of negative 2, so let's say, oh boy, well, if x has a value of, I don't have to pick negative 2, I could just pick negative 1. I would have a y value of 3. And I only need 2 points to draw a line. So I get something like that. And that's it. That's the graph of that piecewise defined function. Alrighty, finally here, the last one, number 12, it says list the 3 transformations and write the resulting function in each step. To get the graph of the function negative 2 times the quantity x plus 1 squared plus 2 from the basic graph of y equals x squared. I'm actually going to list 4 transformations rather than 3. And here's how I would go about doing it. I'm starting with the graph of x squared. I'm not even going to call that a step, but let's just say I am given x squared. Okay, if I take that graph and I shift left 1 unit. So if I shift it to the left 1 unit, that's going to produce x plus 1 quantity squared. See, I'm getting a little closer. Okay, now if I do a vertical stretch by 2, that gives me y equals 2 times the quantity x plus 1 squared. I'm getting a little closer to where I need to get to. Now if I flip the graph about the x-axis, that gives me y equals negative 2 times x plus 1 quantity squared. And then finally, if I do a vertical shift up 2 units, I get negative 2 times x plus 1 quantity squared plus 2, and I'm done. So that's how I would list the transformation in words and the corresponding function that would be produced. So, well, I guess that's it. This is like a video solution for sample test 1 or practice test 1. Hopefully this is all making sense. Hopefully you looked at the study guide, you did the practice test, you're feeling confident, and you're ready to go knock out test 1. So good luck on test 1. Thanks for watching.